That volume should be okay, shouldn't it?
No, that's just a £4,000 screen.
Right, I'm going to plug in the speaker here and blow the thing. There we go. Right, we've still got another, what, 1, 2, got another 3 people to come here. I must remember about the timetables. We're not giving them out today, though, are we?
We'll
just have a look at them first. Then.
Yeah. Oh, yeah.
Okay.
No. We've got 4 weeks, John.
Yes. Okay, thanks. Folks, if I can get your attention here. So, BAM Construction. Is it the BAM Group, David, or is it BAM Construction?
BAM Construction.
Okay. I'll just turn this down a wee bit. Okay, so David's kindly agreed to give us a presentation. There's 2 presentations. This one's going to cover building information generally, a little bit of an introduction to some of the conventions, some of the standards, the pathway, I suppose, David, yeah? The pathway looking at, you know, the lower level of BIM and then the higher levels of BIM. Okay, and I'm sure he'll have some sort of graphic representation there or something along those lines to show you. So I'm going to hand it over to David and I'll just let him explain. Okay, so thanks, David.
Okay, I'll just share my screen. Okay, should be seeing that now.
Brilliant, yep, that's it.
Okay, so I've got 2 PowerPoints. The first one, it only takes about 5 minutes. It's just to try and provide a wee bit of a foundation for the topic. And then the second presentation is the main one. So I'll just go into this one first. Okay, so it's just to provide an overview of what BIM is, when in a project it's used, how and why. And yeah, this is very high level, very basic. It's just to try and provide you with a wee bit of an understanding of generally what it's about. So the background to BIM, it wasn't until the year 2000 that the first BIM software package was released. So that's a software package which allows you to model in 3D, but also embed information into that model. So there were software packages before then which allowed you to kind of produce 3D models, but they weren't intelligent models, so there was no information embedded within the model. So that was 2000. There's several key government reports into the construction industry as a whole, which have sped up the move to BIM. So when we look at these, we're not just thinking about using 3D models. These are really covering information production and management during construction, and what information is delivered to the client by the contractor at the end of the job. So at handover, you would normally think of a building contractor handing over a building to the client, for example, a high school, but they don't just hand over the building. We hand over loads of information as well, which traditionally would have been ring binders and that kind of thing, and probably wasn't used very much. Now it's largely, unless particular clients really need it on paper, It's done digitally. And with BIM, we're handing over a 3D model as well, at least on projects that are the size that BAM work on. So what we're actually handing over is a building and a kind of virtual double of that building in the form of a 3D model. So these government reports, the Lothian report is very well known, and this is a quote. So he called the construction industry an industry which was ineffective, adversarial, fragmented, and incapable of delivering for its customers, and was in need of a major culture change, adopting far more collaborative working practices. So you see his solution to the problem is it's not specifically to use technology, it's a culture change and to adopt more collaborative working practices. So that's what we're going to be looking at in lecture number 1. It's the collaborative working practices side of things rather than the 3D model side of things, because the 3D model is a way to achieve this. It can help you work more collaboratively. It can help you provide a whole wide range of benefits to the client, which really helps to solve the problem the construction industry was facing. So yeah, so today it's more the standards and practices that we're going to be looking at. Sorry, I think I heard someone trying to get into the meeting there.
Yeah, somebody's coming in here. I'll just admit them. Yeah.
Oh, you're able to admit them. Okay.
Yeah.
Yes. Okay.
Tanya.
So the Egan report was 1998, and here you see that he's starting to bring technology into it. We know new technology to be a very useful tool in the exchange of design information throughout the construction team. Defects and snagging need to be designed out on the computer before work starts on site. Redesign should take place on the computer, not on the construction site. So here he's really starting to, they're really starting to see how technology can help the construction industry deliver for its clients. And the focus here is not so much the collaboration. It's actually just what that software can do for you, which is you're building it, you're building on the computer first, and then you're building it for real. So you're building it twice. And that's a big part of what BIM is about, trying to coordinate the designs from various different consultants and subcontractors in 3D, trying to fix everything so that when we get to site, we already know the design works because we've already built it. We've just built it virtually. So these government, and there's several other government reports there, but these are the only two I've got quotes from because they're the kind of key ones which just help you to understand the background to the subject as a whole. Just trying to think if there's anything else to say on that. Just to note that a lot of it's government driven. It's important to kind of understand that backdrop as well, because what we see is government clients, councils and so on, and they know that they're supposed to want BIM, but they're not always that well educated on exactly what that looks like, and we'll get to that later on. So just a brief kind of introduction to the BIM model itself. Now, I'm conscious BIM model doesn't make sense because BIM means building information model or building information modeling, but you just hear people calling it the BIM model all the time. So it's just what everyone uses. So there's 3 elements to a building information model. You've got a graphical model, and that's purely just the geometry. It's basically just a picture. So if you were to, there's various pieces of software, SketchUp being one example, that you could download and you can start drawing in 3D. There's a game, I don't know if anyone's played it, called The Sims, and that's basically what you were doing. You could throw up walls, throw a roof on and so on. But it was just a graphical representation. There was no data embedded in what you'd done. So the second element is the non-graphical data, and this is information that's held within the model and can be extracted. For example, when you draw a wall in Revit, it's automatically got all the quantities built in. So the length of the wall, the height of the wall, the depth, what it's made up of, the various layers, insulation, and so on, the cavity. All of that is kind of contained within the model. So it's an intelligent model. And the third element is documentation. So drawings, schedules, reports, specifications, they're all produced from a combination of the graphical model and the non-graphical data. That's probably hard for you to kind of understand just from this slide alone, but as we model, we can kind of set up the sheets, and if you just take, for example, a ground floor plan, a drawing of the ground floor plan, that ground floor plan updates as you model in 3D. So as you move the walls here and there, put doors in, windows, your drawings are just updating as you go, and they're ready for you to just hit the button, export, and your drawings are exported. So it's no longer the case that we've got one guy doing all the drawings in CAD and another guy trying to copy the drawings as in separate software, and he's trying to produce a model, and you're trying to get these, to match each other. It's all done in one software. So in a lot of cases, the main reason they're actually using the software at all is to produce the drawings, because on site the drawings are still king. That's what subcontractors are building off, but it's so much more efficient than it was before. You've still got companies up and down the country, and they're not using this. They're using AutoCAD. So when they make a change on, let's just say, an elevation, they decide to move the window over a wee bit, they have to then open the floor plan drawing separately to move the window to match to the same location. If they forget, the two drawings contradict each other. This can't happen when you're using BIM software, because it all talks to each other. If you move something in one view, it's automatically moved in the other view, including in the model itself and in all your drawings. So that's a kind of brief introduction to what the 3D side of BIM is and how it works. So in terms of when and how BIM is used, or the model, the answer is just all the way throughout. So that conceptual design stage, this is when you're just almost testing different ideas, trying to get an idea of what kind of building you want. Obviously doing that in 3D is far better for the client, because they're actually seeing a visual representation of what they're going to get. So it's much easier for them to provide feedback than if you're just doing this using drawings. It's also much faster to produce designs using BIM software. If you're doing it using AutoCAD or just on drawings, it takes ages to draw the lines, to try to get a working drawing together. Using BIM software, it's really fast, because there's shortcuts for everything. You could throw up let's just say, for example, a steel model in next to no time, because you've often got things at like on a grid. So for example, a grid would often be set out at maybe 4 meters apart, and you've got steel columns at 4 meter centers throughout the building. Using BIM software, you can basically type in that's what you're going to do, and it just draws it all for you. So there's an automation built in to the software that makes it really fast to draw up designs really quickly in 3D. So it's a really powerful tool at the conceptual design stage, because it doesn't take you long to test out different designs. That's then obviously refined, detailed design analysis. So again, this comes back to the intelligence of the software. Once you've started to build your building in 3D in the BIM software, you can then start to there's energy tools, lighting tools built in, so you can start doing an energy analysis. What's heat retention going to be like in this building? And it runs the calculations for you based on the materials that you've said is going to be in the walls, and how big the windows are, and so on. But all that is built into the software, so it's really, really powerful. Documentation, which we've mentioned, fabrication. So I know that a number of our steel subcontractors, they'll actually use the model for fabrication. So whatever they use to actually fabricate the steel, it uses a 3D model to manufacture it. So their model has to be right, because it's what's used to actually manufacture the steel. And so it's what's manufactured matches exactly the model itself, which is great, because it means we've got a really, really detailed model down to the nuts and the bolts, which is quite good for the client to have handed over at the end. Construction 4D and 5D. So in the BIM world, 4D is a reference to planning. So that's when we take the construction program that we've got and we link it to the 3D model. So that involves, for example, selecting the foundations and attaching the dates from the construction program to those foundations. And then you get to the floor slab, and you input the date from the program to the floor slab, and then you do that just for the whole building. And at the end of it, you can basically press play, and it just plays a video of your building going up exactly as your construction program says. So I think that the second lecture will show you exactly what that looks like. But it's a really powerful tool for checking that your construction program makes sense. 5D is a reference to cost. So that's when we're using we're able to click a button and extract quantities from the model, and they all get pushed into an Excel sheet or something like that, and we can then start to assign costs and rates to those quantities. And yeah, you're basically able to use the model to get a really accurate cost of the project, which is pretty good as well. Logistics, yeah, that's kind of similar to the 4D thing. You're able to play a video of how you plan to do things in 3D. Operation and maintenance. The people who are going to operate the building, they're obviously getting a 3D model handed over, which is a mirror image of the real building itself. And there's all sorts of data inside that model, manufacturer's data, model numbers, serial numbers, all that stuff. And all that can be used by the facilities manager to knowledge is power. That the more they know about their building, the better. It saves them loads of time, makes things a lot more efficient. And that's largely what that talks about. When you get to renovation or building extensions and so on, it's obviously a massive benefit to have a 3D model of your existing building, because you're not having to kind of see what's behind walls and all that. Your 3D model tells you exactly how this building has been built, exactly what's above the ceiling there, behind the wall there, under the floor there, and so on. And you can then build your kind of extension 3D model and attach it to your existing building model as well. Okay, so moving on to why to use BIM. So as I touched on, for the public sector, UK government has mandated that BIM is used for projects over £5 million. The phrase, which is now outdated, is BIM level 2. And that all that really means is that the project has to be done in accordance with a set of BSI standards. The BSI standards just obligate the client, contractor and subcontractors to do things in a certain way, to manage information in a certain way, and that involves the 3D model as well. I'll touch on later why this term is the most well-known term, BIM Level 2, but it's no longer current. It's out of date now. So in Scotland, there's a BIM grading tool for projects above 2 million. So projects are assessed for whether BIM will be used. The reason for that is, well, you've got really small projects, so below £2 million, for example. The software is quite expensive to invest in, so you'll often find that the design team, the contractor involved in those projects, don't have the software, and they don't have the experience. They maybe don't have the BSI and ISO accreditation and stuff like so. It just becomes a lot more complicated. And where you've got small design practices, there was basically a big debate about how fair it was to force them to spend a lot of money on software, which they just don't really need for really small projects that they do. See, if they're doing like a house extension or something like that, it's not really worth the cost of investing in BIM software just for a small project like that. It's fairly simple to do it using AutoCAD. Still faster if you did have the BIM software, but it's just that question of training and the cost of training itself and the cost of investing in the software. Okay, and in the private sector, there's no legal requirements, so it's completely up to them how they do things. But the size of projects that we work on anyway, we find that models are always required, really. I don't think we don't work with any clients who don't see the benefit in requiring the design team to produce models and to coordinate their design and to hand over a kind of digital twin of their building at the end. They're not always quite as fussy about the standards being followed to a T, which would be what BIM Level 2 would be. Strictly speaking, if your project is BIM Level 2 compliant, you're really following the BSI standards closely, and that's what the second presentation here is really going to be about. What kind of things you have to do to comply. Okay, so in terms of why you want to utilize BIM, and this is why private sector clients, although they're not obligated to, they do choose to use BIM. So this curve, what it's showing you is your ability to impact costs is at its highest point right at the beginning of the project concept stage. It's completely up to you. You know, you can make whatever decision you want to save money. So your preferred design workflow is to do your design work here where your costs are low. But traditionally, and this one is your cost of design changes. So obviously at the beginning, it doesn't cost anything to make different decisions. The cost gradually goes up. So at this stage, you've got design work going on. So the costs involved are really having to pay an architect to redo that plan and, you know, redo your model here and there. But as you get to construction, the cost of design changes is huge because you're actually knocking things down. You're impacting your construction program because there, you know, if changes are required, it can be done, but not necessarily to the timescales that we'd originally planned. So the costs really shoot up. And this is the traditional design workflow. So what really this is saying is that if you can move your design workflow as early as possible, you can save a lot of money. So that's really where BIM comes in. If you're able to produce a coordinated model really early on, then you're saving a lot of money, and what you designed at this stage is what's eventually built, and you've de-risked significantly because you've already checked that everything fits, everything's coordinated, we don't have clashes, we don't have ducts and pipes running where we already have steel installed, so you have to divert it. The cost, so the cost of that kind of thing builds up. If we're using BIM models properly, and if the crucial thing here is to appoint these designers early enough in the design workflow. Often they're not appointed until it's kind of too late, and the contractor, we're often not appointed until it's a wee bit too late to really do some of this. But this is the vision. This is what they're trying to get to. This is real. This is a BAM project as well, and a BAM model. So just a summary of the benefits: greatly enhanced early collaboration, accessible project information, better understood design, better tested design, complex tasks automated because we're using advanced and intelligent software. And obviously the benefits are efficiencies in time, cost and materials. So these are benefits that everyone understands. So if I jump over to the main presentation now, keep an eye on the time as well. Yeah, we're only half an hour in. So this shouldn't take a full hour at all, probably between half an hour and 45 minutes, depending on how quickly I go through it. So lecture number one, and this is what we're doing today, is looking at the BIM standards, or information management standards. Now there's 5 kind of main ones right now. The series is ISO 19650. So they were BSI standards, but they're in the process of being updated to ISO, which just means that they're now international. So they decided to try and to collaborate with other countries to try and get everybody to agree on as much of this as possible. It just makes things far more straightforward when you've got some contractors who are international working across borders. The second lecture will be just looking at the model itself, the various things you can do with it, how to use it and operate it. So on paper, that's a more interesting lecture, I'm not going to lie, but it's important to kind of understand this as well. So thinking back to the Lothian report quote, this is really covering that side of it, collaborative working practices, trying to obligate the client, the contractor and subcontractors to work in a collaborative way and to adopt best practice as much as possible as well, so that when you go from when a client, like let's just say Glasgow City Council, they've got two schools being built on different sides of the city by different design teams, different contractor, they shouldn't be dealing with completely different ways of producing information. But traditionally, that is what you would have. The documents, they would be sent by the two contractors, would be named differently, formatted differently, and you know it wasn't a very efficient way of working. So today's lecture is about the information that's being delivered rather than the building that's being delivered at the end of a project, and how that's done as well, starting from the client. Okay, so an overview of ISO 19650. Okay, so at the top, these are the kind of sections of the standard, and I'm just going to give a fairly brief overview of what they're trying to achieve. So in terms of the format of the slide, it's what they say and what they're trying to get you to do and why. Okay, so at the assessment and needs stage, this is where the ISO standard is setting out that the client should be defining what information they require at quite a high level. So that would be if it was a school, what kind of information do we want from the contractor so that we can maintain this building as efficiently as possible. So at that stage, they would speak to their facilities management, whether it's a subcontractor or maybe it's their own guys, janitors and so on. What information would be useful to you when we get the keys? So that would be, you know, they might say we want to have manufacturer details for, you know, every piece of plant we've got in this building, not even just plant, but maybe just assets, doors, windows, and so on. And this is where they're kind of thinking about what their own experience of maintaining the building. You know, a window broke and I didn't even know what manufacturer it was. Took me ages to find a model number and so on. So they're starting to think about what should they be requiring, what's going to be useful to them, when that should be delivered. So that's throughout a project. So a client is within their rights to say, I want this information at this stage. So maybe before the construction's begun, they get a handover of information. During construction, you normally don't, and then at the end there's a handover date. And this is what wasn't really done in the past. But ISO 19650 requires clients to actually think about how information is to be produced and exchanged, reviewed, delivered, and so on a project. And the reason why that responsibility has been pushed onto the client is that, well, they're there at the beginning. A lot of other companies, including us, BAM, we're often not appointed until quite far down the road. And if you haven't had collaborative working practices set up right at the beginning, you're going to have problems because everyone's been doing things their own way when they were appointed. So the client really has a responsibility to set up standards at the beginning, to set up procedures and methods for how they want things to be done. The reference to CDE there, that's common data environment, and you can think of it as a kind of Dropbox type thing, really, because it's where everybody shares information and exchanges information. So it's not to be done by email or WeTransfer or various other services. There should be a kind of cloud storage place set up where everybody uploads their information and downloads their information, and any information exchange happens in that one place. Quite a simple concept, but you'd be surprised at how it's just not often done. It also provides everyone with easy access to the latest information. The CDE, it'll tell you when things were uploaded, when things were revised. It lets you access previous revisions of drawings if you need to, and so on. So it's a far better way of sharing information and accessing it compared to email and servers and things like that. Okay, so if you don't follow these practices, the purpose for information might not be clear. So that's a high level information requirement. If a client doesn't take time to think about why they need what information they need and why they need it, the purpose might not be clear. And if it's not clear why, so what we often find is that clients will have a template information requirements document, and they'll just send that out, and they haven't given it a second thought. They've maybe just taken it from another council, and they don't actually really understand what they're requiring. So ISO 19650 is trying to get away from that by forcing the client to think about what they're requiring. Otherwise, they might be wasting money because the contractor and subcontractor, they're going to price based on those requirements, And if the client's asking for a whole pile of information which they don't have a purpose for, they've got no intention to actually use it. They basically get dumped with loads of information, and they've got no idea how to use it. So they've wasted money in forcing us to do it, and it's often been challenging to actually pull that information together as well. So purpose is really important, and the contractor are within their rights in the ISO 19650 process to challenge the client on why they've asked for that as well. Collaborative environment not set up. So that's what I was touching on. If you don't have that Dropbox type thing set up right at the beginning, you've got loads of information getting lost in emails. People don't have access to the information they need. They don't even know it exists sometimes. They don't know that document was even there because no one told them. So if these processes are followed, a clear purpose is for information is defined, and only information that the client has a use for is delivered. It's quite a big problem for clients to ask for way more information than they actually know how to use, and often the reason they're doing that is because they think they have to, because they misunderstand the government mandate. They think it means they have to ask for a pile of information, whereas actually it's the mandate just requires them to go through this process to really decide what information they need. A client should never be asking for more than they need. Consistent approach by the whole team in information production. So that's the how side of things. So these are just a few examples. So at the assessment and needs stage, one of the documents which a client should be producing is an information standard. This is a BAM template. It's just one page from a BAM template, because although we're a contractor, not a client, we've had to produce a template because we're finding that ISO 19650 was released only a year and a half ago. Clients don't even know, so they don't have any templates made up. So if a council comes to us and they don't have any of these templates, we just say, just use ours. So one part of it is to have a common coordinate system set up for your models. Now again, just to note, this is being done right at the beginning, at the assessment and needs stage. Often it's not done at this stage. So what that means, having a common coordinate system, is that when you is that all the models they kind of have a shared coordinate system. So one model, normally the architect, will set up a project base point. So these are real UK Ordnance Survey coordinates. They'll share that with the rest of the design team, and their models will kind of acquire those coordinates. So what that means is when you link one model into another, so when you're merging the models together, the model just falls in the right place. You don't have to manually move anything because you've punched in the correct coordinates. Surprisingly, this is common sense, but it's often still not done, even on big projects we work on. I'll open a model, I'll try and link in all the other design team models, and they don't come in the right place. So you have to figure out how to move them. You have to tell them, can you set up can you adopt the coordinates from the architect's model, please? So again, really surprising that these things aren't done. But ISO 19650, it forces the whole delivery team to do this right at the beginning, and for everyone to be using the same coordinates. Another example is naming convention, which almost everybody in the construction industry hates, because they like to be able to name their drawings in whatever way they want. But the ISO 19650, and this predates ISO 19650, goes back to like 2008, 2010. But the construction industry has taken absolutely forever to actually adopt it. So it's often not really policed. But what it's saying is every file on the project, literally everything, drawings, reports, schedules, should be named according to a naming convention, which is defined in the standard. So You've got a project code, so a code that's unique to that project. An originator code, so that's BAM or the name, a code for the architect or anyone else in the design team. Volume is kind of like a zone in the building. Level, so 00 would be ground floor, 01 would be first floor. XX just means it's not applicable. So if it's not a drawing, if it's a report or something, then these things aren't applicable. Type of information, RP is report, DR is drawing. Role, W is contractor, A is architect, S is structural engineer, and then a unique number. So the vision here is that you've got everything, you've got all the kind of files for the project in the CDE, which is your Dropbox type environment, and you can filter by any of these fields to find the information you need. So if you only want to find information that's relevant to level 1, you filter by the level field and you put in 01, and then you've only got drawings that are relevant to level 1. And then you want to filter it further by the subcontractor who produced that drawing, you can do that, and so on. So yeah, again, it's quite incredible the variety of naming conventions that have been in place up until this is being utilised. Every company had their own way of naming drawings, and it was a total mess. Now everyone on a project should be naming their files exactly the same way. So this page just defines model export methods and procedures. Yeah, just steps to go through when you're creating your export view, and the settings to adopt, stuff like that. These are all things which should be defined in your methods and procedures document, which again should be set up by the client. Now, obviously, most councils don't have experts at this stuff. I'm using council as an example just because they're a public sector client that we often have. So they'll have a consultant, a BIM consultant, kind of produce these documents, and these are people who really know what they're doing, and they're almost like policing that the contractor and the whole design team, the architect, that they're all utilising best practice in what they're doing, and that they're all working consistently. Because you'd be amazed at the trouble we have with inconsistent export settings being used. One of the problems we have with that is if you don't do this consistently, you might actually get models again not coming in the same place. So you try and open a merged model in a piece of software, and your structural model is 1 mile away from your architect's model just because of a tick box. So again, it's about trying to embed best practices in the procedures for a project. Okay, so moving on to invitation to tender. So at this stage, the client is producing detailed information requirements. So they've moved away from just high level, what are we looking for, and now they're actually detailing. So what documents do we need handed over? Exactly what information do we need about our assets, about our boiler, and that kind of thing. Reference information is just if it's an extension, for example, to a building. So we've got an extension to a primary school just now. Reference information would be any information that you already have about your site, about your existing building. So drawings, models, everything makes it far easier to then build on that and design for your extension. Shared resources. So this is a requirement for the whole team to not be doing the same task several times, but to kind of share their resources where possible or where it's beneficial. An example of that would be so clash detection is something we do between the models. To carry out clash detection, you need to have clash tests, which is a file. So you've got a clash test file. So it doesn't make sense for every team to produce their own clash tests manually, when you can just share that file and everyone can use it. Saves everybody time. So again, these are client activities, and ISO 19650 is trying to get the client to think about how they can save their team time by providing them with shared resources. And if you've got a really good BIM consultant, he'll have a whole set of files that he can tell the whole team, use these files, and it'll save you loads of time. Tender response requirements is pretty self-explanatory. Tender evaluation criteria as well. So again, this is an invitation to tender. So the standards are just requiring the client to make clear their response requirements and how they're going to evaluate the responses from the contractors as well. So again, the standards here are trying to avoid late additions to the requirements by forcing the client to think through their information requirements at the invitation to tender stage. This is almost never done. Clients, they rush out their invitation to tender without adequately defining their information requirements. They just haven't given it much thought often at that stage. They're focused on the building, understandably, but they neglect to think about the information that they're going to require. Late additions to requirements, if you think back to that McLeamy curve, it costs more the later it is, even when it's information. Sure, some information you can require late on and it doesn't cost much, but often it does cause you problems. The earlier the information requirements are kind of made known, the less likely it is to incur costs, partly because you've got to think about, is our team even capable of meeting these requirements? If you think of that physically, if you've got a massive complex building, if you didn't tell people until after the tender had been awarded, actually we've decided to adopt this new design, which is really complicated, and the contractor didn't price for that, and they don't actually have the experience or capability to do that. It's the same with information. There are really kind of complex ways of producing information using BIM software, and yeah, these things just need to be defined really early. So requirements known before appointment, if this is done properly, precision in stating exactly what's to be delivered and when. So I'm going to look at an example of an information requirements document from a client. Now, as you can see, it's incredibly complex, and you probably won't be able to make head or tail of it. So I'll just try and walk you through it really slowly. So you'll notice that this is an Excel. So the information requirements are being set out row by row. So here, acoustic strategy report. This is a row, and here we've got what's being required and how it's to be delivered as well. So an acoustic strategy report, some of the information that they need in that report is being defined there. Exchange format, is a template available? So that would be a shared resource, no. And then there's some kind of classifications there, so you can filter by the classification. So those columns are kind of dealing with the information deliverable and the requirement, why it's being required. So a good information requirement document will define why it's being required. This one here is form of information. Who's to deliver it? Who's going to be responsible for delivering it? So receiving party and accountable party. And then when it's to be delivered. So you'll see there information delivery milestones. These are RIBA stages, so those are just stages throughout a project, and often these reports they're to be delivered at various stages because they get updated as the project goes on. So that is a good example of a client's information requirements document, because they're really adequately defining what they're requiring, and all the kind of important bits, why, who, when, and so on. That is actually a DFE template, so Department for Education in England, but it's a document that has been used on BAM projects, and it's one of the best that I've seen. Now, more typically, Excel is not used. We get information requirements just in narrative format. So who's to deliver it, what's to be delivered, when, and why is normally ignored. So this is a way information requirements have been communicated, basically in like 50-page documents, and you have to kind of go through it with a fine-tooth comb to try and actually identify the individual requirements. And it's really hard to manage that. If you compare that to a schedule format, BAM as a main contractor, so you can see here in blue there, these are documents that have been assigned to the contractor. BAM as a main contractor reassign that or allocate that to our subcontractors. Now in this format we can easily do that because we can just select that row, and assign it to the M&E subcontractor or the structural subcontractor and so on. And you're able to manage each individual information requirement really well. If you imagine trying to do that when you're dealing with massive documents in narrative format, it's almost impossible. And this is what the industry has been doing for a lot, well, very often anyway, up until now. Luckily now clients are a bit better informed, and ISO 19650 has really pushed the industry towards using that kind of schedule format for defining information requirements. Moving on to the tender response by the main contractor. So this would be where BAM come in. First two sections have been the client. This section is BAM. So now our tender response, we're saying who's going to be carrying out the information management roles. We're producing a BIM execution plan, which is our plan to deliver the information that's just been required. So that covers absolutely everything in terms of how we plan to meet those requirements. Assessing team capability. So again, the standards are requiring us to carry out an assessment of our team. Do we have experience of doing this? Do we have the training we need? Do we have the software we need? And not just BAM, but our subcontractors. Who do we plan to appoint to do this? And do they have the training and the skills and the software and hardware that they need to meet the client's requirements? For example, we had a project down in Ayrshire, and the council wanted, the most complex model we could possibly produce, but they wanted us to use subcontractors within a radius of 50 miles or something like that, or maybe even less than that. Whatever it was, it was two things that couldn't go together because the subcontractors with that advanced capability just didn't exist in that locality at the time. So it's the standards force us to really go through this process of de-risking, making sure that everything works, and carrying out an assessment of the capability of your project team is a really important part of that. Mobilization planning is largely a matter of resolving anything that arises from the assessment that you've just done. So where you carry out your assessments and you start to kind of evaluate the responses, you realise we are lacking experience in quite a few areas here. This needs to be resolved. Your mobilisation plan is where you track that you've resolved everything, and you're then ready to produce information, and you've kind of dealt with those risks, which is where assessing risk. Again, the standard is forcing us to follow best practice, industry best practice, by assessing risk to everyone really, not just to us, to the client as well. An example of a risk would be where we've carried out we've carried out our capability assessments. We've realised the architect, for example, he's never used BIM, he's never modelled in BIM, but the client has required advanced BIM model. Can we upskill the architect? Can they acquire the software they need? Can they get their team trained in time? All of that. We would have to put in the risk assessment that until that's been done, that's a major risk. Okay, so if you don't do it, you could be winning work with teams not capable of delivering, which is a big problem. A key part of that is where our surveyors, commercial team who appoint subcontractors aren't aware of this. So that's where communication needs to be good within a company as well. So within BAM, I could be aware of the information requirements on this job, that we need to be producing a 3D model. If the commercial team aren't aware, though, if I haven't communicated that to them, they could be concluding appointments with teams who are not capable of meeting those client requirements. Okay, I think I've covered those. So again, just to give you a kind of real example, our capability and capacity assessment, we've put it onto Microsoft Forms to make it as easy as possible to send out to our kind of design team, subcontractors, and to make it as easy as possible to collate those responses. So they can be filled in either on a phone or on the website. We just send them a hyperlink, they click in it, and they will answer all the questions that we've put in there. Those questions are designed just to make sure that we're not going to have any issues in terms of knowledge, skills, experience, or availability of the software that they need. And yeah, oh, sorry, I think that broke up there. Can you hear me now?
Sorry. Yeah, David, we can hear you now. There was just a little bit of a pause there.
Yeah, that's okay. Might have been my Wi-Fi.
It was only for a few seconds. Thanks.
Yeah, okay. I'll just jump back in there. Hopefully it doesn't happen again.
No worries.
Must be my Wi-Fi. Okay. So yeah. So we kind of carry out our capability assessments of the team using this form. They respond, and their responses automatically get collated into an Excel sheet, which is really helpful because we can then automatically feed those responses into our mobilization plan. Our mobilization plan kind of goes through every step of what we need to do to make sure that our team are capable of delivering according to our BIM execution plan, and in terms of meeting the information requirements as well. So we've got conditional formatting. So as the forms are filled in on people's phones or on the website, this gets automatically updated with their responses, and it gives us a dashboard view of basically where we need to carry out training, or where we need to acquire software or whatever. By the end of this should all be green. So as we carry out training, we turn this green, and we're demonstrating to the client, but also just for our own purpose, that the whole team have now been trained and are capable of delivering. Risk register. So you're just identifying the risks, the consequence of that risk, and you're kind of detailing your mitigation measures to try to eliminate that risk altogether. We were working on, so I was on a course recently, and they were introducing us to what they call the bow tie method of risk assessment, which is far more complicated, but I'm not going to go through it in detail, but just very briefly, you're identifying a threat. So client not being informed is a threat, and then you're setting out a preventative barrier. invite the client to meetings as early as possible to help them define their requirements. An escalation factor is if that one doesn't work, the client does not engage with the request for help, and then a barrier to that is to reach out to BAM senior management to get them to speak to the client. And if that fails, the risk event occurs, which is that you have insufficiently defined or poorly formatted information requirements received from the client. And then recovery planning, you kind of go through a similar process. The first recovery barrier there is to create, so that's basically to create a BAM EIR to supplement the client's one to try and fill any gaps. An escalation factor is if that fails, recovery barrier not implemented prior to appointments being concluded. So again, it's really forcing you to try and think through what could possibly go wrong, and if those things go wrong, what barriers do we have in place to try to kind of mitigate the damage. So that's just another kind of real life example of a risk assessment or a risk register. And again, this is industry best practice, ISO 19650, forcing contractors to kind of go through those processes. So at the appointment stage, so in terms of the BIM execution plan, these are the activities that we're carrying out: addressing any feedback from the client, agreeing changes to their information standard, because we receive these documents from them. It doesn't mean that we can't make changes to them. We might come to the client and say, look, we're aware of better ways of doing this, or we think these standards might cause us some issues. Can we make these amendments to make things a bit smoother? Things like that. The contractor is the one who has to implement these things and actually carry them out. So the BIM execution plan is the vehicle by which we communicate these things to the client. Agreeing information delivery strategy. So that's the bulk of the BIM execution plan. It's setting out how we're going to deliver this information. Enabling technologies are the technologies that are required to enable you to carry out that strategy. So again, it's the industry standards forcing us not just to kind of say what we're going to do, but to really think about what are you going to use to do that? Do you have the software that you need? Is everybody aware of it? Okay, so these processes avoid an inadequate or a vague delivery strategy, and if you don't do it well, if this isn't done collaboratively, you could have a disengaged design team. So the design team aren't engaged in producing the BIM execution plan, and if they're not contributing to it, you might find that they're just not aware of really what it says, or you might just be losing out on their experience and their expertise, because they've often got more experience than the contractor in the production of information, because they're obviously the ones who do it. So there's various kind of things that go wrong if you don't follow these processes. If done well, you've got a clear strategy that addresses the client's information requirements, and you've got a design team who are engaged and they're contributing with their expertise as well in terms of what's going to be done. The next stage is where responsibility is assigned for the production of information. And this is done in a responsibility matrix where we list out all our information deliverables, and we make sure that somebody is assigned to each one. If you don't do this, you might just find that something's fallen through the cracks. Some tasks aren't allocated to anybody. Responsibilities can be ambiguous if that's not done well. You're obviously trying to avoid that. Another step that we're to carry out here is, so as you saw earlier on with that kind of schedule of information requirements, what this stage is where we allocate those requirements down to our supply chain. So the requirements kind of cascade down to the right person. So client, they just assign it to the contractor, to BAM. It's up to us to reallocate that to the person who's actually gonna do it. Information delivery plan is where you're really, it's basically your design program. So you're starting to put dates against the information deliverables. So you've assigned responsibility already, but now you're actually putting together a kind of program. This is when the information is going to be released, and this is who it's going to be produced by. Again, if that's not done well, milestones might not be agreed or binding in appointments. These are appointment documents. So once these kind of dates and deliverables are agreed, they're binding on the supply chain. Dependencies not being established, so that's a really important one. The structural engineer, for example, might need information from the architect so they can produce their information. And if they're reliant on them, then a delay in the production of that information affects them and the delivery of their information. So a good program will establish these dependencies so that there's visibility kind of over the impact of delays to information in being produced. And it's important that everyone is aware of that, because if you're aware, if I don't get this done in time, that's going to have a ripple effect. It's going to impact him. If you don't think it affects anyone, you know, it's not. You don't have the same urgency to get it done. So done well, you've got deliverables listed alongside delivery dates. Everything's up to date, and you've identified risks, which is what I was talking about there with the dependencies. So this is an example of a responsibility matrix. Again, very complex when you look at it like that, so I'll just break it down a wee bit. So here we're defining what information is being produced. So these are just assets. So this is really the production of 3D information. We do have a column to identify where it's not being done in 3D. So these are kind of, yeah, assets, elements in our building. So that's what's being modeled or produced. This is who is doing it. So these are company codes. So we've got architect, M&E, and so on. So each kind of element in our building is assigned to a particular team. And at the top is when. So RIBA, plan of work stage, and information delivery milestones for this particular project. So we don't necessarily have a delivery milestone at every RIBA stage. So those are identified there as well. The LOD, that just means level of detail, and that's kind of defined by another kind of international standard somewhere else. But you're defining what level of detail is your model going to be at various stages of the project. So at the beginning, the level of detail number is low. By the end, it's right up to 5. So again, you've got a really clear plan of how the model is developing and who's developing it. There's one example there, rainwater, where the architect develops it up to a certain stage, and I've got TBC there, but a subcontractor would maybe then take that over and develop the model to the next level. Mobilisation plan we've already looked at, but we've gone to the mobilisation stage. So this is really moving from planning what we do to doing what we plan. So here we're kind of doing what we planned at the tender response stage, because we produced a mobilisation plan at the tender response stage, but now we're actually mobilising. So now we're carrying out the training, making sure we don't have any gaps in capability. We're configuring everything, so we're making sure our common data environment is set up properly. Everyone's got the access they need to upload and download and edit and so on. And we've tested everything, so now methods and procedures. We've got various procedures for, you know, coordinating models, clash detecting, all sorts of things. If you don't test it, you'll find out further down the line that you might have issues. We've often just got issues with pretty basic things. Sometimes people have issues uploading their models because their models are too big and the system, it won't let them upload. It'll just say upload failed. You don't want to have uploads failing at the stage where people need that information straight away. So at the mobilization stage, you're trying to really make sure you're not going to have problems. At a critical stage, you're trying to make sure everything runs smoothly before you even begin the production of information. In reality, it's very hard to really carry out this mobilization plan properly before information is produced. Normally, it's carried out after information has already begun being produced. But the standards are trying to get the whole construction industry to implement best practice and to adopt these best practices as well. I've touched on these, the kind of things you're trying to avoid, delays to systems being set up, and that's a real thing as well. We're working with a client just now. They're trying to set up their common data environment, and they're telling us there's delays, there's problems, and it should really have been set up months ago. So that is causing us real problems. Done properly, people are available, educated, trained to carry out their roles. Software and hardware are set up in advance, and all your plans have been tested in advance as well. Okay, so moving on to the production of information stage in the standards. You're creating information, sharing it, and reviewing it, and there's various processes for this to be done. It's really just making sure that task teams are checking their information before they share it, that they're following procedures to make sure, basically to try and avoid mistakes, wasted time, that they're adopting the export settings for their models and so on. Again, just trying to make sure people are working consistently and following the same plans. Again, if not done well, you've got so I should have actually said at the review stage, this is where you're reviewing information. So that's a kind of really key stage, especially in terms of 3D models, because that's where you're carrying out coordination checks on the model, clash detection. You're trying to really refine your design to eliminate clashes, eliminate what will become problems on site. So that's why I'm saying here uncoordinated information. You're trying to avoid oversharing of information. So again, your procedures should set out when information is shared. Oversharing is just a waste of time. Incorrect information being delivered. So that's going to happen if you don't have really good methods and procedures for reviewing information. And if incorrect information is delivered to the client, it's bad news for everybody because it's a waste of time. It could it results in rework being done, which is a waste of time for the people doing that work. It also results in delays to payments being made to the supply chain, which nobody wants, and that's what results in that adversarial culture, which those government reports refer to, and that's what we're trying to get away from. So done well, we've got clash avoidance. So you're avoiding clashes by following best practice for producing models and for coordinating models. Information is only shared when it's ready, so you're not wasting time by sharing information for no reason. Client receives the right information, and ideally first time they don't have to send it back to us to carry out rework. Just some screenshots, just because there hasn't been much visual in this particular PowerPoint. So just a wee look at the 3D, and this is what lecture 2 will really kind of go into detail on. But here you can see a coordinated model. So you've got an architect's model, you've got your structural model in there as well, and you've got M&E. So your models merged together, and the BIM software, it's very powerful. You just click a button and you get loads of results for where you've got clashes. So again, in fact, I've got an example of a clash here, bottom left. Well, it's not a hard clash actually. It's we've got a steel beam right in front of a window. So clash detection wouldn't have actually picked that one up, because if they're not touching, it's not a clash. And this was actually a real example from a BAM project years ago, and that was built like that because, thinking back to that McLeamy curve again, it was too expensive to fix it by the time they'd realised, and it only happened because they at that time weren't utilising BIM software the way they should have been. Because if they just walked around the virtual building, they would have spotted that. But they were probably relying on working in 2D, and they just didn't realise that there was a clash there. The structural engineer probably didn't realise there was a window there. The architect, he clearly didn't know that there was a beam there. So that's a real example. This is just an example of a clash result. Pipes going right through a steel beam. So those pipes have to come down. And again, if that's happening on site, you've already started to set things out at that level, and they're realizing they're going to have to divert the pipe down, try and go under it. They're hoping they're not going to catch the ceiling as they do that. These are things you want to design out in 3D before you get to site. Otherwise, there's delays and costs to addressing these problems on site. This one here so that's a builder's work hole in a concrete wall for M&E to get through. So this is a duct, I think it is. Yeah, I think it's a duct. And again, we've got software which automatically produces those holes. Well, not quite automatic. There's a process that we go through, but the M&E consultant, he'll propose the holes where he needs them, and the structural engineer will, in his model, he'll open it up and he'll see all the holes that have been proposed. He'll review them one by one, hit OK, and the hole is produced. And what that means is his builder's work drawings have been updated with those holes. So the concrete will be cast with those holes in place. It's a major cost for contractors on site to have to make these holes after the concrete has already been cast. It's really, really costly. So there's a major saving to using the right software to coordinate the M&E with the holes at that stage. This one here is another example of one that isn't a clash. So I'm looking top right here. It's a ceiling which is too low for the door. Either that or the door is too tall, and I haven't looked at it. But it's a kind of a visual clash, and something needs to change. But what this is software which is again really smart, and what it does is it'll kind of virtually open your doors and make sure the doors don't touch anything. Traditional clash detection, it doesn't check your kind of door swing. It just clash tests as it is standing. So that's a kind of new level of intelligence in the software, and it helps us to pick up issues like that at the stage of production of information. Okay, almost there. Not much really to cover in these last couple of slides. Information model delivery. So this section in the ISO standard, it just sets out some procedures for the contractor to review and authorize information prior to submitting that information to the client. So again, trying to avoid that waste of time in incorrect information being delivered to the client and all the problems that causes. the standards are forcing the main contractor to make sure that they've authorised everything before it's then submitted to the client. We've now got software where we can set up approval workflows. So this is kind of done digitally and done automatically. So here you can see an approval workflow where there's 1, 2, 3 steps before it comes to a final approver. So the initiator, that's a person who's uploading information, and we can add as many people or companies or roles to there as we want. So they would upload, let's just say, a drawing that they want to submit to BAM to be authorised. And when they submit it, it automatically goes to reviewer 1, who we just set it to the role of design manager. So the design manager reviews it. If he's happy with it, he's only got 1 day according to this to do that. So that's demanding. If he approves it, it goes on to reviewer 2, who is probably the architect. So they've got 14 days to carry out that review. And if they're happy with that, in this instance, it goes back to the design manager. But if we're using this example, that would then go to the client. So again, digital approval workflows are really, really good compared to having to track these things in Excel, constantly chasing people up with emails. This way, it's all automated, and you've got that kind of control and governance over the review procedures. Okay, so trying to avoid unchecked information being submitted to the client and then being rejected. If we do these things properly, we've got a lower chance of information being rejected by the client because it's been reviewed and authorised by BAM first. And project closeout is basically just that a lessons learned exercise is carried out. Everyone knows to carry out a lessons learned exercise as best practice, and yet it doesn't get done on a lot of projects. I think BAM are good at doing it. We do carry it, but in general, delivery teams, they just move on to the next job. They don't stop to kind of assess things. Where you work with the same client repeatedly, there's extra benefits to doing this because you're working often with the same team, and you're in similar circumstances. So it's easier to try and address things that didn't go well, and opportunities for improvement. So that's really that's really it. Hopefully that gives you an idea of how international standards, and this has been pushed by the government, forces contractors and delivery teams as a whole, including the design team and even clients, to manage information more effectively and to adopt industry best practice. I don't actually know. I had an example of a lessons learned there. It's not, I think we all know what lessons learned is, but it's just a description of what didn't go well, the consequence of that, and a recommendation to improve. This is not a real example. It's just a test. But yeah, that hopefully gives you an idea of what, when people talk about BIM requirements on a project, or if they mention BIM level 2, what it means is that the whole team are being kind of forced to follow these industry best practices and processes to try and achieve what the Latham report, was laying out 26 years ago.
David, thanks very much for that. I honestly wasn't expecting such level of detail. It's astonishing. So thanks again. Guys, we've probably only got time for a few quick questions, but maybe if you can go back over the recording of this when we do that, you can think of maybe more questions to answer in the next session, which will be 2 weeks' time, David, yeah?
Yeah, it's a fortnight, yeah.
So has anybody got any quick questions? For me, I've written down 3 things that actually start with T. It's the technology, you need the training, you need the time. I'm sure there's all the things there that you need, but The amount of training that you must have to do a lot of hand holding and guide the client through all the various
Loads.
pieces, subcontractors. It's just the amount of training that's required for this, and I hope
Yeah.
we can play some sort of a role in that in the future, you know, and the time as well.
Yeah, there's loads of training having to be carried out.
Chris is here, my colleague, so I don't know if Chris has got any queries or.
Well, sorry, hi there. I was just wondering, execution of this on site, when you're on site, what's the level of technology that you need on site for everybody to participate and view BIM for the actual building of the stuff when you're there? Because back in the day, you had a set of drawings and that was that, or you had multiple sets of drawings. But now it looks like you're going to need iPads, you're going to need computer systems, Wi-Fi.
Yeah. Well, there's a lot of improvement to be made there. All our guys have iPads, so in theory, they've got access to the model on their iPads. In practice, it's really hard to really interact with a model on an iPad using your fingers. So we still build off drawings. We don't have subcontractors, you know, using 3D views to build. However, it is much easier than it was before to incorporate 3D views and pictures into drawings, because people are producing drawings from Revit now, so you can easily kind of drag a kind of 3D view of that part of what you're kind of showing in your drawing into the drawing. So you're able to benefit from it that way. But we've got all sorts of technologies that we're using on the iPad, but not that much is directly related to the model. The model primarily benefits in terms of design, making sure everything fits. We're still building off drawings on site, even though we've equipped our whole team with iPads. They're mainly using their iPads just to do things digitally, so digital checklists, taking photos of everything, and sometimes recording information to do with assets like serial numbers and stuff like that. But yeah, I don't know if that answers your question.
Yeah, it does. It's what I suspected as well.
Yeah.
Okay, that's brilliant. Thank you, David.
Anybody else there want to fire a question? Do you want to shout it out there, Bruce?
Just as a back to what Chris was saying, on the site, when you're working on site and you've got all the guys with the iPads and that, is there somehow a line of checklist that follows through that you can see that they've done, or if you've inquired about that? Is there a way that this system does that too? You know, so you can see if you send out an instruction you want this to be seen to, they go through it. And is there a way then that you can see that what that's asked has been done?
Yeah, I think I heard you. Yeah, all our checklists are digital, so we can kind of assign them to subcontractors, and they get an email pop up, and they can click the link, and it'll open at that checklist that they're supposed to do. It doesn't have like an automated reminder or anything like that, but by having everything done digitally, we can kind of produce dashboards on what checklists have been done this week, which ones haven't been done, has the weekly fire checklist been done or not. So we can identify remotely these kind of problems now, because these kind of things, it's an obligation. You have to do it legally. So when that was on paper, you couldn't know if your sites were doing these things. But yeah, it's all digital now, which does allow us to do these kind of things.
Okay, thanks. Anybody else got any quick questions? Or, like I said, go back over the recording, right? Maybe pick out little bits that you're maybe not sure about, you want me to clarify, and maybe we can fire this at David. But again, David, I just want to thank you again, because that's a long session.
Yeah, I didn't expect to fill the hour and a half.
Okay.
Are we all okay with that, folks? Sorry, Chris.
Yeah. No, I'm just about to say thank you very much.
Thanks
See you in a
again.
fortnight.
No problem.
Yeah, brilliant, David. Thanks again.
Okay.
I'll be in
Thanks. Cheers.
touch afterward. Thanks again. Bye-bye.
All right. Bye.
It will stop recording as soon as he hangs up.
Yeah,
Don't know how we get access to the recording.
we're just seeing how we can stop the recording, David, but I'll just press leave here anyway. Okay.
I think David's gone.